Hey, welcome back. So in our last video, we had a frequency distribution dealing with number of children that employees had, right? And what we want to do, we want to introduce some terminology. First of all, we want to talk about what lower class limits are for a class. So when you're dealing with a class, lower class limits are the smallest possible whole numbers for that class. So for example, when we look for the first class, 0 to 2 children, the smallest possible whole number is 0. That's a lower class limit for the first class. The second class, the lower class limit would be 3. And for the last class, from 6 to 8 children, the lower class limit would be 6. So those are our lower class limits. As for our upper class limits, those are the largest possible whole numbers for a quantitative class. I'll circle those in blue. So these are going to be the 2, 5, and 8, right? Those are the largest numbers for each class. So 2, 5, and 8 would be upper class limits for those three classes, respectively. All right. So just some terminology. The next thing we'd like to do is actually show you how to construct a frequency distribution, a quantitative frequency distribution from some raw data. So we're going to give you some steps for doing that. So constructing a quantitative frequency distribution from raw data. Okay, so the very first step, and maybe the most crucial step, is finding the class width. Finding the class width. We're going to tell you exactly how that works. There's going to be a formula that you want to use for finding the class width. So here's the formula. The class width is going to be equal to the following. So what you're going to do, you're going to take the largest number, which we call the maximum, or the max for short, minus the smallest number, the minimum, or the min for short, and divide by the number of classes that you want. I'll just write number of classes. I'm going to tell you how many classes I want you to have. So the maximum minus the minimum divided by the number of classes, and after you compute that number, you're going to go up. Now what do I mean by go up? I don't mean necessarily round up, but go up. So for example, if I got the number 5.7, I would then go up to 6. If I got the number 5.1, I would still go up to 6. If I got the whole number 5, I would still go up to 6. So you always go up. You don't round up, you go up. Okay, so that's a big deal, finding the class width. After you find the class width, the second step is to create 2 columns in a table. Create a table with 2 columns. Create a table with 2 columns. On the left, you want your classes, and on the right, you want your frequency, and you want to label those columns. All right, so that's the second step. So step 3, what you want to do is list all your lower class limits. List lower class limits. So Your very first lower class limit is going to be the smallest number. So begin with the minimum. Begin with the minimum. That'll be your first lower class limit. And add the class width to find the successive lower class limits. And add class width to find successive lower class limits. Okay, so you start with the smallest number for your first lower class limit, then you add the class width to find the next, then the class width to find the next, and then the class width to find the next until you've found all the lower class limits. You stop once you've gone through the number of classes you want. We'll see that later. All right, so now what we need to do is list the upper class limits for list the upper class limits. Now remember, you're listing these in the class column, right? Lower class limits and the upper class limits go in the class column. So list the upper class limits. So these will be one less than the succeeding lower class limit. So the lower class limit that follows the upper class limit will be one less than that. We'll see that in a moment. It probably doesn't make a lot of sense to you right now. We'll see it. It's pretty easy when you do it in practice. And finally, for number 5, what you want to do, you want to tally up the number of data values that falls in each class. And write the frequencies in the frequency column, and write frequencies in the frequency column. All right, so let's see if we can follow this set of instructions. We're going to do a real practical example. Now, we're going to construct a frequency distribution from scratch. So here's an exercise. Exercise during summer of 2012. Oops. Mr. S, that's me, Mr. Smeaton, polled his statistics class. So I did a survey one day. About the number of hours spent watching TV each week. So I took a survey about how much TV they watch per week. The data is below. Call this raw data. The data is below. So here I just have listed the number of hours students watch. So first someone said 3 hours, someone said 20 hours, it's a lot of TV, 5 hours, 4 hours. Now notice I'm only putting whole numbers. I told them to round off to the nearest whole number for the number of hours. So I didn't want any decimals. I wanted to make it simple. When you have decimals, it makes it a little more complicated. 15 hours, 7 hours. Someone said 3, someone said 5, someone said 3, someone said 9, someone said 13, someone said 2, someone said 6, someone said 10, someone said 2, someone said 6, someone said 21, someone said 11. Okay, so it looks like there are, 4 people going down and 5 people going across, right? There's a total of 20 people, right? 20 data values. So, yeah, you got 20 people here, and then the numbers represent the number of hours each person would watch TV. So my instructions here are to construct a frequency distribution, construct a quantitative, I'll just write quant for short, quantitative frequency distribution. With 5 classes. For the data set. So we got a data set. All right, so we're going to say done here. All right, so what was the first step? Anybody remember the first step? Class width, right? Class width. So here we go. We're going to find the class width. So what we're going to do, we're going to take the largest number minus the smallest number. Oops, I can't spell min, can I? Thank you. Min. Divided by the number of classes. And we're going to go up. I'm going to go up. What's the largest number in our data set? Hey, we got to go back. What's the largest number here? If you look carefully, you should see, look, 21, right? That's the largest number. You don't see any numbers bigger than 21. You got 20, but 21 is the biggest. So 21 is going to be the max here. What's the smallest number that you see here? The min. Looks like 2, right? 2 is the min. And how many classes do we actually want here? It says 5, right? Construct a quantitative frequency distribution with 5 classes. So the number of classes here, let me scroll this a little bit. Number of classes should be 5 down here. Okay, so I'm going to take 21 minus 2. Let's see if we can do that. So I'm going to go up of, so what's 21 minus 2? 21 minus 2 is 19, right? And that's divided by 5. So 19 divided by 5 is 3.8. So we got to go up from 3.8 to what? Well, 3.8, you're going to go up to 4. 4 is equals 4. So I'm going to write here the class width is 4. I'm just going to circle that. All right, once you have the class width, you can start constructing your table. Where are we going to construct the table? Do we have enough space? I think we do. I think we have enough space up here. I'm going to put it in, I'm going to sneak it in here real small if I can. I'm going to write 2 columns. The first column here, I got my classes. My classes represent, remember what we're talking about, numbers of hours of TV. Numbers of hours of TV. Hours of TV. So these are going to be your classes. Then on the right-hand column, we're going to have the number of students. Students. These are our frequencies. I'll just write FREQ for frequency. I can't fit it in. All right, so we're going to begin with the lower class limits. How do we start with lower class limits? You remember what we did, or what we said we would do. So for step 3, begin with the minimum and add the class width. So we're going to start with the minimum, 2, and then we're going to add the class width to that to get the next lower class limit. 2 plus 4 is 6. Then to find the next one, 6 plus 4 is 10. And then the next one, 10 plus 4 is 14. The next one, 14 plus 4 is 18. Now I'm going to stop at that last lower class limit of 18. Why do I stop there? Anybody know why we stopped there? Well, remember we said we wanted 5, right? 5 classes. Notice I have 1, 2, 3, 4, 5 lower class limits. So now what we're going to do, we're going to put little dashes. And now we're going to put the upper class limits. So the upper class limits are going to be 1 less than the following or the succeeding lower class limit. So right here, we're going to put 5 right there. Why are we going to put 5 right there? Why should we put 5? Oh, man. Why does 5 go right there? If you think about 5 is 1 smaller than the 6, which is the next lower class limit. So 5 is 1 less than 6. For the next upper class limit, we're going to put 9. Why 9? Well, 9 is 1 less than the 10, which is the next lower class limit. And then we're going to put 13, right? Because 13 is 1 less than 14, which is the next lower class limit. And then for this next upper class limit, we're going to put, 17, right? 17 is going to be 1 less than 18, which is the next lower class limit. Now, we can't do that trick where we're doing 1 less than the next lower class limit on this very last upper class limit, and that's because there is no next lower class limit. But how do we figure out the very last upper class limit? Well, notice that you're going up by 4s on the upper class limit. 5 plus 4 is 9, 9 plus 4 is 13, 13 plus 4 is 17. So 17 plus 4 is going to give you 21. So we're actually adding the class width to each upper class limit. Okay, and we stop there. All right, so that gives you all of your lower class limits, your upper class limits. So we got 2 to 5 hours of TV, 6 to 9 hours of TV, 10 to 13 hours of TV, 14 to 17 hours of TV, and 18 to 21 hours of TV. So the very last step would be step 5, and step 5 is about tallying things up, right? So we got to figure out how many of these data values falls between 2 and 5. Let's see. So 3 is between 2 and 5 hours. 5, 4, 4, 3, 5, 3, 2, 2. So everything I checked off with a red mark is going to be between 2 and 5. So how many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like 9. So 9 students watch between 2 and 5 hours of TV. How about 6 to 9? 6 to 9. I'm going to check off 7 is between 6 and 9. 9 is from 6 to 9. 6 is from 6 to 9. And 6 is from 6 to 9. How many is that? 1, 2, 3, 4. 4 of those blues. So 4 people watch between 6 and 9 hours of TV. Okay, now I'm going to do the 10 to 13. So I'm going to check off this 10 here. I'm going to check off this 13 here. This 10 here. And this 11 here. How many is that? 1, 2, 3, 4 of those yellows. So between there are 4 people, right? 4 students that watch between 10 and 13 hours of TV. How about 14 and 17 hours of TV? Let's see, 15. What else? I think that's the only number, right? The only purple number there. 15 hours is between 14 and 17 hours. So, yeah, just one of those. And then finally, for 18 to 21, 18 to 21. 20 and 21 would do it. 1, 2. These 2 dudes right here. 20 and 21. So it's just 2 of those that are between 18 and 21. Okay, so that's it. That's your frequency distribution right there. I snuck it up in the corner next to the data set so I didn't have to scroll around, but there it is.